All right. So in Strength of Material 2, Lecture 5, we are going to be looking at shear force and bending moment 4. Very good. Our lecture outline, okay, is composed of the introduction, the shear force and bending moment. If you see SF, shear force, BM means bending moment, okay. So if you see shear force and bending moment diagram for simply support beams, that is where we are going to focus on. We are going to be drawing the shear force and bending moment diagram of simply support beam, and also we are going to do some work examples as well. Okay. Someone is asking that why is it that we didn't look at lecture 4 but we are looking at lecture 5? Very good. You can see that if we go to lecture 4, this is the slide of lecture 4 I'm having over here. If you go to lecture 4, it is just like lecture 5, but lecture 4 is composed of the formulas. Do you understand me? Yes, the formulas of how the solution went about. Very, very, very good. But in lecture 5, we're actually going to put this into what? Practice. Do you understand me? Yes. So instead of looking at the formulas, which may confuse you more, I wanted us to look at something practical to enhance your understanding. Okay. So you can look at lecture 4 later after the solution to lecture 5, and life is going to be much more easier. So let's focus on lecture 5. And in lecture 3, we learned about computation of support reaction for various types of beams, including simply support beams, cantilever beams, overhanging beams with internal hinges, and lecture 4 was shear force and bending moment diagram for standard cases. This lecture, that is lecture 5, will be focused on drawing the shear force and bending moment diagram for simply support beams. Okay, that is, we are starting with simply support beams. Last year, simply support beam came in exams. Last 2 years, simply support beams came in exams. Your main focus should not be on the exams, but you should focus on learning to understand how this is done and how the calculation can be done in order that you can draw the diagrams very, 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 very well. Let it be part of it because it is something you're going to apply in real life. Very good. At the end of this lecture, you should be able to write the shear force and bending moment equation for simply support beams using the method of section. Also, you should be able to calculate for shear force and bending moment values at salient points. Okay. You should also be able to draw the shear force and bending moment diagram for simply support beams. Determine maximum and minimum shear force value for the diagram. As simple as what? ABC. Okay. Take note that we are going to be taking some various caps. Yes, we are going to be taking some various caps just from whatever we learned from lecture 3. Lecture 3 was mandatory for you to understand, because if you don't understand lecture 3, you may not be able to understand lecture 4, you may not be able to understand lecture 5. Yes, so you should do well to be able to calculate for the support reactions and do the check in order for you to get your 0. If your check does not check, it means that you have to go over the work again. Very good. So after the check and you realize that everything is fine, it means you're going to be taking some various caps. Do you understand me? If you want to consider the left hand side, this is the diagram you're going to be drawing. If you want to consider the right hand side, this is also the diagram you're going to be drawing. Do you understand me? So you put this symbol over there like that. Yes. But if you want to consider the right hand side, anywhere you take a cut and you consider the right hand side, you put this symbol over there, that sign over there. So this is the sign for the right hand side also. As you can see, as simple as that. Okay. This end that you are going to be seeing in most cases is your neutral axis. Okay. So don't get confused. And anywhere you see vein, just know that vein is the what? Shear force. Vein is the shear force. Don't confuse this vein for the ones we were calculating for when we were calculating for the support reactions. Those ones are reactions, vertical force at A. But this one, we are talking about the shear force. They are all the forces that are moving in the y-axis. Okay, so don't confuse that. Grab that. Good students, you have a pen, a paper, and a calculator beside them. so that as we dive deep and begin to make some calculations, they can be able to participate to enhance their understanding. Very, 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 very good. Okay. Yeah, so these are the moments over here at your team. Let's look at some basic terminologies, and then we see how best we can begin to solve some problems. Okay. Yes. So this is our analysis procedure. That is the determining of the internal forces using the method of what? Section. Determination of the internal forces using the method of sections. Okay. So you should say that we are going to be cutting some sections, we are going to be taking some sections. One, what are we supposed to do? We are supposed to draw the shear force and bending moment diagram as we learned in lecture 3. 2, you calculate for the reactions. You see, at least you get some mark. Cut a imaginary section through the member perpendicular to it as is at the point where the internal loading is to be determined. Also draw a shear force. Also draw a free body diagram of the segment that has the least number of loads, indicate the unknown resultant, that's the neutral, the shear force, and then the moment acting in the positive direction. In your point 5, you should be able to write the equilibrium equation for the internal forces. That is for N, V, and M in terms of what? X. Also, you should be able to calculate for the internal forces for the sections considered. Draw the axial force, shear force, and bending moment diagram. Also determine the salient points of the diagram. That is the maximum and minimum moment and points of contraflexion. Okay. So those are the salient points. I just want to quickly highlight it to draw your attention to it. Okay. So that if you are being asked one day, what is the salient point or what are the salient points about, you can be able to say that, oh, these are the maximum and minimum moments and points of contraflexion. As simple as that. As simple as ABC. Good. So this problem you're having over here, problem 5.1 says that what? Draw the shear force and bending moment diagram of the beam shown below. Okay, so you are supposed to draw the shear force and bending moment diagram of this beam. I hope we all know how to calculate for the support reaction, because that is basically the first thing you are supposed to do. Unable to do that will cause you to lose marks. Do you understand me? Very, very good. So let's proceed. So this is a problem over here, problem 5.1, which says that draw the shear force diagram and bending moment diagram of the beam shown below. So this is the beam we're having over here. Very, very, very beautiful. This is the beam we're having over here. So what are we supposed to do if we are being asked to solve such a problem? We say always we come and write our given. Okay. Always you come and write your given. Then after writing your given, you continue to draw the diagram again for 1 mark. For marks, okay, and then from there you proceed with what you are supposed to do. So let's quickly put the given down and see how best we can all become history. Good students should do well to type their questions in the comment section. I'll do well to review it for them. Thank you. Exactly. So after you are done putting down your given, you come and write over here what original problem, just as I have done over here. Just as I have done over here. You see that this is the question that they gave us. Yes, you have to come and draw the diagram again so that you get a mark. Don't skip it. So that is what I have done over here in the given. I read you the diagram, and then I have written over here original problem. You see, very good. From there, what can I do next? We are going to the what? Solution. Okay, we are going to the solution. Over there, we can write solution, and then we continue from our free body diagram. Okay, so I'm just going to put solution over here like this. So this is my solution. Please do well and solve all the trial questions for lecture 3 before it's time for even midterm or exams. Do well to solve all the trial questions. Okay, not for lecture 3 alone, but all the lectures that we have done so far. These are some of the things that will enhance your understanding. Okay, so over here, what are we going to do? We're going to draw our hot free body diagram. We said a free body diagram is just a line diagram. So let's draw just a line over here. And you realize that the beam is in this form and it has hot. Over here is a hot. Over here is a fixed, let me say a hinge support. So two reaction, roller support, so one reaction that we can put the forces and calibrate it. Okay, the intervals are 3, 3, 3, 3. As simple as that. Okay, so at the left hand side, I can write out this. I can put this over here. That is my horizontal force at A. This becomes my vertical force at what? A. In this case, I'm going to use what? Reactions. You understand me? So this also is it. And then we can say that this is our horizontal force at what? A. HA. You see? And then this is going to be my reaction. What? Reaction A. This is also going to be my reaction. What? D. This is point D. Don't get confused. This was point A. And then they told us that here is what? 20 kilonewton. Here was also 20 kilonewton. As simple as ABC. As simple as ABC. So this is 20 kilonewton. You see? kilonewton. This is also 20 kilonewton initially. You have to draw the free body diagram so that you don't lose the mark. Yes. Then from here, what are you going to do next? You have to come and write over here free body diagram. Calibrate it nicely. This is 3 meters. This is 3 meters. And then here was also what? 3 meters. All this I'm doing over here is essential. Don't skip it. Good students should do what? Practice with me as I'm also working. Don't stay behind. Failure to do some of these things is what will result you to face challenges when you are alone. If you're also doing them now, at least you can be asking questions along. Yes. And then that will enhance your understanding. Very good. Good students should do all to subscribe to the channel. Don't forget to hit on the notification bell so that anytime I release a video, you will get a feedback and you'll be able to watch. Very, very, very good. Okay, so this is the diagram we are having over here. We are left with one thing, and what are we supposed to do? We write over here what free body diagram. Then you realize that in this case, we are not leaving any mark behind. You see? So this becomes the free body diagram. Free body diagram. As simple as ABC. Then from here, now we can now start taking our hot moments. Okay. So first of all, I want to take the moment at A. We also come and take the moment at hot D to calculate for reaction A and hot reaction D. Who are the reactions? These are the reactions that we are going to be calculating for. This guy and this guy, they are the reactions. You see? So you are supposed to know reaction A, you are supposed to know the reaction D. So the first thing I'm going to write over here is what? Taking moment at A. So we write over here, taking moment at what? A. So that is it. We said that we want to take moment at A. We want to take moment at A. After you are done writing this like this, what did you say? Try to write the symbol down. The symbol, the rule. Okay. And then the rule is what? We are using anti-clockwise movement to be positive. That is what? All forces that are moving in the anti-clockwise direction are what? Positive. As simple as that. Okay. Better still, sum of all forces, or in this case, we are doing movement. Okay. So we say that sum of all movements about A should be equal to what? 0. Okay. So that is the rule. So from here, we can proceed. So the first one, assuming that you put the compass over here and you open to this point and you take the moment, what distance is covered? It is 3 meters that is covered. So the 20 is going to multiply the what? The 20 is going to multiply the 3. Take note that it is always force times perpendicular what distance. So it is actually 20 times 3 and not 3 times 20. If you do it the other way around, we'll mark you down. Good. So this is performing a what? This is performing a clockwise movement, so it is negative. So put it into brackets nicely, and you come and write what? Negative what? Then you open brackets 20 times what? 3. You can now close the bracket nicely. As simple as ABC. Then we go and take the other moment too. You can't put any symbol over there because you don't know what the moment is about. We say that all clockwise moments are hot, negative, and all anti-clockwise moments are positive. Now we are done taking this one. So we come and open to here. Still, this is our origin. So if you open to here and you follow the direction of this, it is also taking a clockwise moment about this origin. But the distance that will be covered from here to here is what? 6. So we say 20 times what? 6. But it is also what? Negative because of it is moving in a clockwise direction. So this becomes negative what? 20 times 6. Good. You see, we are moving. We are making progress. Then the last one is going to be what? If you are standing over here, A, and you open to what? D, that is the last point. If you take this reaction, realize that this is going to take a what? An anti-clockwise what? Moment. We said anti-clockwise is positive, so it's going to be what? Positive what? RD times the whole distance. 3 plus 3 plus 3. And that is what? 9. Okay. So RD times 9. Reaction at D times 9. So this becomes what? Positive. You see? Very, 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 very good. So positive what? Reaction at D times 9. Then from here you can equate everything to what? 0. Good students should do all practice this as I'm also doing. You should do all to punch this all together. 20 times 3 is going to give you what? 60. But you add a sign, so it becomes negative what? 60. In other words, the negative sign affects everyone that is in the bracket. 20 times 6 is going to give you what? 120. So this is going to give us minus 120. Okay, good. Also, I bring my positive sign, and then this is going to give me what? 9 RD. Then I can equate all of this to what? 0. See, from there I can equate all of this to what? 0. Good. So from here, it's no more physics. The rest is what? Mathematics. So just make reaction D the subject, and life is much more easier. Good. Negative I don't really want us to waste much time. So if you do the substitution at the end of the day, what are you going to get? This is going to give you negative what? 180. Okay. Plus what? 9 RD, which is equal to 0. Finally, if you group like terms, you are going to get 9 RD is equal to what? 180. So if you divide both sides by, let's say you come and divide here by 9, you divide here by 9, you are going to get your reaction D to be what? 20. Okay. So let's all do that together. Let's all do that together. Let's all do that together. So that is 9 RD is equal to what? 180. I intentionally repeated it again so that if I do the division, you can still see it clearly. So I divide here by what? 9. And I come and divide here also by what? 9. So this 9 will take care of this 9. Better still, let me use a different color pen. So you realize that this 9 will take care of this 9. And finally, we can say that what we are going to get what? Our RD to be equal to what? 20 kilonewton. So you know that the reaction at D is equal to what? 20 kilonewton. As simple as that. As simple as ABC. From here, what are we going to do next? We are also going to take moment at what? D. Just as we did for the initial one, we took moment at A. We're going to take moment at what? D. You see. So we have now calculated for reaction RD. We know that RD is 20. We want to know reaction RA. What we are going to do is that now this is where we are going to take the moment. We are going to take the moment at D. You see. So this is going to be our origin now. This is where we are going to be standing with. This is going to be our pivot. Do you understand me? This is where we are going to be standing with the compass to take the moment now. So you realize that we have already calculated for reaction D. So it is reaction what? A that we are going to be looking for now. So bear that in mind. Bear that in mind. Very good. Very good. So we are going to write over here taking moment at what? Taking moment at D. So this is it. Taking moment about D. Taking moment about D. So that is it you are seeing over there. And then this is it. So what is the next thing we do? You go and put the rule over there. Failure to bring the rule will cause you to lose marks terribly. Yes. So this is, we say positive, that is all moments that, or we are going to take all anti-clockwise moments to be what? Positive. Okay. That is sum of all moments about point D. Because we are talking about D, that's what I'm saying, sum of all moments about D. It should equal to what? 0. And it is true too. A moment at a point is equal to 0 because all the no distance is covered. So 0 times, let me say, a force times 0 is still 0. You understand me? Yes. So that is it. So we are going to start. I can intentionally start by opening the bracket down very well nicely like this, and then we wait for the variables that are going to be in. Okay. Yes. So here, what are we going to do next? because of the origin issue we spoke about, watch carefully. Watch carefully. We are standing here. If we open to here, you realize that a distance of what is covered, 3 meters. So if you follow the direction of the arrow, this is actually a an anti-clockwise movement. So it is actually positive 20 times what? 3. You see, positive 20 times 3 meters. The other one is also going to be hot, positive 20 times 6, because a distance of 6 would have been covered. You see. So they are all taking anti-clockwise movement. So that is it. So this is what? Positive 20 times 3. 20 times what? 3. Okay, positive is positive, anti-clockwise movement. And the other one also anti-clockwise. That is the distance that will be covered is 6. So this is actually 20 times what? 6. Okay. So from here, you realize after the first one, if you stand over here with your compass, what is going to happen? The distance would have been what? 20 times 6. Because if you stand over and open to here, a distance of what? 6 meters is covered. So 20 times this 6, you see. As simple as that, just like that. And then the last one would have been what? If you stand over here and you open to here, RA. This moment is actually what kind of movement? This is a clockwise movement, so it will be negative. So this is negative what? Negative RA times 9. The whole distance is 9. You see, as simple as ABC. So I'm going to write negative RA times 9. RA first because that is the force. Okay, times 9. And then it is left with one person to consider. The other person you are supposed to consider is the what? Horizontal force. Okay, is the horizontal force. Because we are taking moment over here, we have to consider the HA2. Okay, so we say that HA times 0. Okay, HA times 0. HA will always multiply 0. As simple as that. Because there is no distance over there that it can cover to multiply. Do you understand me? Yes, so that will be plus what? Look at the direction that HA is moving in. It is positive. So that is what? HA times what? 0. Now we can equate all of this to what? 0. About the cardinal point issue that I spoke to you about in lecture 3. If you apply that concept over here, I'm sure you shouldn't have a problem with me. I'll put this over here and I'll not draw it anywhere again. Yes. So that is it. This over here is just like the cardinal point. This is our y-axis. This is our what? X-axis. Okay. I told you the other day that if you consider this diagram that I've just put over here, this guy, this is positive region. This is what? Negative. This is negative. And this is what? Positive. So the direction in which the H is moving over there, it is positive. You understand me? Look at him over here. Look at the direction in which it is moving in. Positive. That is why I say positive HA times 0. No confusion. Okay. This is it. Positive. That's our sign. Exactly. So let's proceed. Let's proceed. Let's proceed. Very good. So RD, RA, this is going to be negative RA because it's a clockwise movement. Negative RA times 9. Very good. From there, we can just simplify. The rest is no more physics, the rest becomes mathematics. On this note, I continue to say that what the laws of physics are the same for all observers in a uniform motion relative to what one another. Someone can also choose to use a different approach to get the answer. Once you get the answer, it is also accepted. But make sure you take the moment well or force first before what distance. Very good. So 20 times 3 is going to give us 60 plus what? 20 times 6 is going to give us what? 120. Yes, 120. And then this is going to be what? Minus 9RA. Minus 9RA. Okay. Plus 0 is equal to what? 0. Finally, what are we going to get? This is going to give us 180. So 180 minus 9RA is equal to what? 0. Okay. So from here, what are you going to do next? You just group like terms and then you can make RA the subject to get your reaction at A. So we said that 180 is equal to what? 9RA. Then finally, you can divide both sides. This over here you are seeing over here is the same as what? 9RA is equal to what? 180. Because if A is equal to B, then also B is equal to what? A. You see? So let's divide both sides by 9. We also divide here by 9. And finally, what are we going to get? You realize that if 9 is going to cancel this 9, and then also now we're going to 180 how many times? 20 times. So you can say that therefore our RA, our reaction at A is equal to what? 20 kilonewton. So from here, what are we going to do next? We can just consider all horizontal forces. That's one idea. Always you should remember to do it, because if you don't do it, you free marks. So if you don't do it, you lose the free mark. Do you understand me? So try to always do it. This is how far we have come. Good students who wish to take screenshots can do well to take them to enhance their understanding. Exactly. So let's go and consider all horizontal forces and we see how best we can make life easier. Okay. So over here we said that we want to consider all horizontal forces. So this is it. Considering all horizontal forces. Okay. So in the consideration of the horizontal forces, you put a rule down. That is the rule we are going to be using, is that all forces that are moving towards the hot east are positive. Okay. So sum of all forces moving in the hot x-axis should be equal to what? 0. The consideration of the horizontal forces, they are actually the forces that are moving in the y-axis. So from here, what are we going to say? HA is just equal to 0. Okay. As simple as that. HA is equal to 0. So finally, we know that the HA, when we calculated for it, what did we get? HA is equal to what? anyone having any question to ask, you can do what, point your questions in the comment section. I'll do what to review them for you. Also, I want to tell you that time appears to move slowly for a body in motion relative to the observer. Some people are not learning because they think that, oh, there is more time. There is more time. So they wait for the paper to be closed before they begin to learn. It is not good. Try to understand the things now so that when it is exam time, you only do what, revise, and life is easier that way. Okay. So please, and a very big please, do well to be able to what, understand some of the things we are learning. Understand it. Don't wait for exam time before you say that you want to learn. No. Good. So let's go and do the check. From here, we come and do the check. And then the check is what? The check is just all about the forces that are moving the wires. As I told you, the one I just did is about the forces that are moving the x-axis. Now we want to talk about the forces that are moving the y-axis also. So that is the check and what the check is about. So from the check, we are now going to start taking our sections. Then you begin to experience what I've been telling you since the beginning. Okay. Yes. So this is the check. And then in the check, we're going to put the rule down. Yes, the rule we have been playing with from basics. The rule we have been playing with from basics. So over here, what is the rule? The rule is that all forces that are moving in the y-axis, that is the one that are moving towards the north, we take them to be positive. Okay. So I'm saying that sum of all forces moving in the y-axis should equal to what? 0. Remember to always bring it. And now we can now consider the check. You understand me? Yes. So let's go and write them one by one and then we come back. Let's go to where we drew the free body diagram. Use the free body diagram for the check. Look at the free body diagram. Who are those moving in the y-axis? If you are talking about the y-axis, the cardinal point I showed you. The cardinal point I showed you. Better still, I can draw it over here. I said that here is what? It has arrows on it like that. Always you draw it. You have been plotting graphs. I'm sure we have all plotted a graph before. So it is not new. When you are plotting a graph, you realize that this place is what? Positive. Here is negative. Here is negative. And then this place is what? Positive. So that is what we're using for the check. For the check, we are considering the people who are in the y-axis. This is the y-axis. This is the y-axis. Okay. The straight one. And then this is the x-axis. So as simple as that. So look, RA is moving in the y-axis. It is moving up, so it is what? Positive. This 20 kilonewton is moving down, so it will be negative. This guy is also moving down, so it will be negative. This guy is moving upward, so it will be positive, you see. So I'm going to write positive RA minus what? Minus 20 kilonewton. You see. Let's go and do it all together and come back. So that is what I'm trying to say, is that here is going to be what? Positive what? RA. Okay, that is the reaction because it is moving upwards. And then the other one is what? Negative 20 kilonewton. Because it is moving downwards. Negative 20 kilonewton. You see. Then the other one too is what? Negative 20 kilonewton. It is also moving downwards. Okay. Let's go back to the free body diagram again. You see, this guy is moving downwards. Look, if you are moving downwards, you are hot. Negative. So negative 20, negative 20. And then the RD is moving upwards. You see, it is positive. So these are the tricks we are using. So this becomes what? Positive what? RD. So I put over here positive R B. You see, very good. So from here, we know reaction A, we know reaction B. It's just a matter of substitution, and then we get the answer. We are good to go. Reaction RA is what? 20. When we did the calculation, we had 20. But take note that anytime you are doing this check, always this answer should be equal to 0. So you equate this to 0. If you don't get 0 at the end of the day, it means that whatever you are doing is wrong. There is a problem with it. So this is what? 20 minus what? 20. Okay. Minus what? 20 plus what? 20. Punch it on the calculator. What are you going to get? At the end of the day, you realize that you are going to get what? 0. Yes, this question came last year. It came last 2 years. Take it very, 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 very serious. So you see how far we have come now. From where we started to where we have gotten to, we came to do the check. So once you do the check and you get 0, it means that whatever you are doing, it is correct. You're on the right path. Very good. So since this is not our main focus, the question said that what? You should draw the shear force and bending moment diagram. It's the diagram that we are supposed to draw. So we are now coming to redraw the free body diagram again and indicate the reactions. Just as I told you, this free body diagram, I'll come and draw it again. Then now, this point, in place of RA and RD, I'll put the reactions over there. The reactions, and the values are 20 kilonewtons. I'll put them over there. And those are what you're going to use to do the cut in order to what? Get our answers to be able to plot a graph. Okay, good. So this is it over here. This is it over here, as simple as that. So this is lecture 5. That is what we are looking at. Very good. Very good. So over here, what are we going to do? I'm going to write the reactions for you to see. So the internal reactions we had, you can see them over there. And over here, the first one is what? This time, we are not going to use any rule, but I want to outline the reactions we had. Okay, I want to outline the reactions we had. You realize that VA was what? For reaction VA, we had 20 kilonewtons. Okay. But we said that we are not using VA, we are using RA. So reaction A, this is also reaction hot B, and then we have reaction hot C. Reaction C. So this one we had hot, but take note, it is just reaction A, B. It is just reaction A and D we calculated for. Do you understand me? So those are the ones that we will just outline. We are not going to outline reaction B. No. So this one is also our horizontal force at what? A. So I'm going to put it down like that. This one we have 20 kilonewtons. This one too we had what? 20 kilonewtons. 20 kilonewtons. And then this one was just 0. Okay, 0 kilonewtons. So those are the reactions we had that we are going to use to draw the free body diagram. But in this case, we are going to indicate the values. Okay, yes, instead of RA, RB, we are going to put their respective values over there. So let's all just take some time to draw the free body diagram quickly, and then we are good to go. So if HA is 0, we just don't put anything over there. This is the beam. So here, over here, there was, over here to there was a reaction. So we know then this is 20 kilonewton. This was also 20 kilonewton. So that is it, 20 kilonewton. We had some 20 kilonewtons at the top here too. Let me quickly put them down. You have to come and do it, draw the diagram again. This is the continuation. Okay, then we come and write the point. This is point A. To sharpen your understanding, let me use different color pen to write the point, because this is where we're going to be considering for most of the calculations. So look, this is A, B, C, and then this is this is D. So this is point B over there, as you are seeing. Let's write the calibrations. This is 3 meters interval. This is also 3 meters interval. And also this is 3 meters interval. Just as you all saw initially. Yes. So over here, this is it. This is it. As simple as ABC. As simple as ABC. So from here, we can now start taking our cuts. Okay. But take note that over here, how many points do we have? How many points do we have? We have 4 points. Okay. So to know the number of portions that you are going to cut is just the number of points minus 1. If we have 4 points over here, that's A, B, C, D, then it means that A, B, C, D is 4. So 4 minus 1 is equal to what? 3. So at the end of the day, we are going to cut 3 portions. Okay. So that is, we are going to cut 1 portion over here like this. We are going to get portion A, B. We're also going to cut 1 portion over here. We're going to get portion B, C. We're going to cut 1 portion over here like this. We're going to get portion what? C, D. You see? But before anything, first of all, let's consider what? Portion what? AB. Let's consider what? Portion AB. So we are going to take a cut at portion AB. I want you to know that anywhere shear force occurs, bending moment takes place over there, because if the shear occurs, the thing will surely bend before it falls. So shear is actually the crack that goes through the thing. If you have a cement block over here like this, and then you exert too much load on it, okay, it can crack. So this crack you are seeing over here is the shear. Then after it's cracked, what is going to happen? It's going to break. It will surely bend. That is it. A simple scenario that I have just tried to put across. So we say we want to consider portion AB. You see, so I'm going to write portion AB down, and then we see how best we can make more history. So this is what portion. So that is portion what A, portion AB. Portion what AB. Very good. So in portion AB, take note that we are going to draw, we can choose to draw the right hand side or the left hand side. You see, if you take the left hand side, life will be much more easier for you because it is very, very small. You can just take the moment around this one small and you are good to go. Or if you want to take the right hand side, so this is this long part you take. Very, very long. So the choice is yours. But I will consider the left hand side. Let's just draw this small one. That is the left hand side. Easy to do our calculation. We are going. Whether you take the right hand side or whether you take the left hand side, you will still get the same answer. It's not beautiful. Yes. So I'm going to draw it. Okay. But before that, we say we are considering the left hand side. So I'm going to put the rule over there. Okay. So let me put the rule over there. So this is considering the left hand side. So that is it. So we are considering the left hand side. Okay. We are considering the left hand side. And then the rule is such that, so this is the left hand side you are seeing over there. And then the rule is such that 0 is less or equal to what? X. Less or equal to what? 3. It's because these are the intervals. Okay. Portion AB starts from what? 0 and ends at what? 3. So always, that is how it's going to be. Okay. So that is how the intervals I have just put over there. So let's draw the portion that I have cut. That is the left hand side. We are coming to draw just the left hand side. We calculate for the shear force values. We also calculate for the bending moment values. Then we are good to go. Do you understand me? Then we are good to go. So I'm going to draw the left hand side now, right away. So this is the left hand side. And this is where the cut took place. So this over here is the origin. That is where we are going to stand with the compass to take most of the cut. And over here was our hot 20 kilonewton. This is our point A. So this is 20 kilonewton. Here now it has break, so we don't know the actual distance now. The thing has break. So we assume it as what? X. We assume it to be what? X. Yes. So this is the left hand side, just as I have drawn, you are seeing. So we come and put the rule over here. The symbol is should if you consider the left hand side, there is a price you are supposed to pay, and that is you are supposed to draw that over there. So you draw this over here like this. You can see that this one is moving towards the south. This one is moving towards the east. And the movement around it is a clock, is what anti-clockwise movement. It's as simple as that. It's not anything too difficult to keep off head. To keep off head. Good. moving downwards is vain. That is the shear force. Yes, that is the shear force. And also, the one moving to this side is the what? Let me use different color pens to denote them, to just draw your attention to certain things, and then we proceed. So this is hot vein. So this guy is the shear force. This is the hot neutral axis N that I spoke to you about initially. This is the M. That is the moment. That is the moment. Good. So after we are done putting our diagram nicely, what are we going to do? Take note that the interval, it is in meters. So this is what you put it by the 3 meters. 0 is less or equal to x, less or equal to what, 3 meters. Then from here, we can calculate for our shear force value. When we are done, we come and calculate for our bending moment values. So I'm coming to write over here what shear force values. So this is it. Shear force values. So these are what shear force values. Shear force values are just the values that are moving in the hot y-axis. It's not anything scary. They are the values that are moving in the hot y-axis. You see. So if they are moving in the y-axis, then the rule we are going to use is the hot. All forces that are moving towards the north are positive. Okay. In other words, sum of all forces that are moving in the hot y-axis should be equal to what? 0. Good. Look at the cut that we took. Now that is what we are going to focus on for our calculations. Look at the cut that we took. If you look at the cut that we took, who are those moving in the y-axis? If you draw the cardinal point, you realize that this guy is moving in the y-axis 20 kilonewton. But it is moving upwards, so it is also positive 20. This guy is also moving in the hot y-axis. This guy and this guy are moving in the y-axis. So you said that hot positive 20 minus hot pain is equal to what? 0. That is all. The rest is no more physics. It's mathematics. You calculate for it, you are good to go. So you say that hot, it becomes 20 minus hot pain is equal to what? 0. Okay. If you make vein the subject, what are you going to get? You're going to get what? 20 is equal to what? Pain. Positive pain. So this means that what? Our shear force values are what? 20. Our shear force value as portion AB is 20. And this one, because there is no variable attached to it, we say that what? This is a constant variation. Okay. So let me use this to denote that. So this becomes what? A constant variation. So this becomes a constant. Because there is no variable attached to it. Then from there, we can now come and simplify. That is, at x is equal to 0, at x is equal to 0, our shear force at A is equal to what? 20 kilonewton. What I mean is that now we know that our shear force is 20 kilonewton. Okay. Failure to write the unit can cause you to be penalized. So let me write it. Kilonewton. Okay. Kilonewton. See. So now come and say that what? intervals is what I'm using. Don't get confused. So at x is equal to what? 0. You see that the first interval was what? Look at here. The first interval was what? 0. Look at portion AB. Yes, the first interval was what? This first interval was 0. And then the other one was 3. So I'll say that at x is equal to 0, shear force at A is equal to what? 20 kilonewtons. Then I also come and say that at x is equal to what? 3 meters. My VMB is equal to what? 20 kilonewtons. As simple as ABC. So it's not anything difficult. Just look at the procedure. Type your answers in the comment section. I'll review for you. So this is also become what? At x is equal to 0, your VA is equal to what? 20 kilonewtons. It's equal to 20 kilonewtons. Okay. Also at x is equal to what? 3 meters. Also at x is equal to 3 meters, our what? Shear force at what? B is equal to what? 20 kilonewtons. As simple as that. You are good to go. 20 kilonewtons. From here, you come and now calculate for your bending moment values also. As simple as that. As simple as what? ABC. So let's come and also calculate for the bending moment values. And we see how bad we can. So this is how far we have come. This is how far we have come. You said that first of all, you calculate for the reactions. Then when you calculate for the reactions, you come and do the check. You consider the horizontal forces. You have to consider them too. You come and now write your reactions down. Draw the free body diagram again and represent the reactions. You take portion AB. So it's just portion AB we have taken. Calculate for the shear force. Then you calculate for the bending moment at that side too. Then when you're done, you come and take portion what? BC2, you do the same thing. Portion CD, you do the same thing. Then you draw the diagram. You can see we are almost done. We are still in progress. Very good. So from here, we're going to draw the calculate for the hot bending moment values. Okay. Yes. So let's go and do that quickly. Yes. So this over here, you have the shear force values, just as I told you. So over here, we are going to do the same thing. Bending moment values. Bending moment BM values. Okay, yes. So for the bending moment value, because we are talking about bending, you should know that bending is actually a moment. Okay, so we put the rule down that is what? Positive. Okay, we are taking all anti-clockwise movement to be what? moment to be what? Positive. Okay, that is sum of all moments about this time. We're going to use O because O is our origin. O is equal to what? 0. You see, as beautiful as that. So from here, what can we say? We're going to be using this diagram. You see, we're going to be using this diagram. So if you stand over here with your compass and you open to here, then you realize that the 20 is going to multiply the x. If you stand over here and you open to here, this 20 will multiply the x. If you take the moment like that, it's going to be what? It's going to be 20 times x because the distance of x would have been covered. Okay. So let's go and do that together. So that is what? 20 times x. But the moment is a what? The moment that it took is a clockwise moment, so it is negative. Okay. So you say that negative 20 times what? X. Negative 20 times x. Then we close bracket. Then let's go and take the other moment. The other one is what? There is no other moment to take back. Actually, there is, from the left hand side, we consider it has a moment, but that moment is what anti-clockwise, so it is positive. So you're going to write plus m. You see, this m is what I'm talking about. This m over here is what I'm talking about. So that is it. So plus what? M. After this, you equate all of this to what? 0. We equate all of this to what? 0. So if you simplify this, you are going to get what? If you simplify this, you are going to get 20x, negative 20x. This is going to give you minus 20x plus m plus m is equal to what? 0. Is equal to 0. Okay. So if you make m the subject, that you are going to be left with what? M is equal to what? 20x. Okay. Because of the variable attached to the moment, it's now going to become what? A linear variation. So the unit is what? Kilonewton meter. Okay. The unit is going to be kilonewton meter for the moment. Take note of that. So because of what you are seeing, this is going to be what? A linear variation. So this is going to be what? We say linear variation. Linear variation. Okay, so this is linear variation. Then from here, what are we going to do next? We just consider it as x. We consider it in terms of portion AB also. You see, so the first one is going to be what? At x is equal to 0, just as we did for the initial one. At x is equal to what? 0, comma, our what? Moment at A, our moment at A is going to be equal to what? It's just 20. Then anywhere you see X, you put 0 over there. 0. See. So at the end of the day, this is going to be what? Your MA, the answer is going to be what? 0 kilonewton meter. Kilonewton meter. See. Then over here, you come and say that what? At X is equal to what? 3 meters. Your what? MB, that is moment at B, is going to be equal to what? 20 into brackets, we put 3 over there because of the X. So you put, because we are using, this is the values we are using for that. Okay, so anywhere you see the X, you put 3 over there. So 20 times 3. And then 20 times 3 is what? So that is going to give us 60 kilonewton meter. 60 kilonewton meter. So that is it. That is it. That is it. So you can see that now we know the moment at A. We know the value for the moment at B. You see, we also know the shear force at A. We also know the shear force at B. So the next thing we are supposed to do, we are supposed to come and now also take a cut at portion BC. You see, we take a cut at portion BC. So we are done with portion AB. You see, so we are coming to take a cut at portion what? BC. We are going to take a cut at portion BC this time. So this is the cut. So if you take a cut over here, it means that because of the cut you have taken, the first one, we don't know, we don't know the actual dimension. You understand me? So the first one will be X, the overall will be X, and then the second one will be what? 3, then 3 minus what? X. That is how its diagram is going to look like. Okay. Yes, that is how its diagram is going to look like. So I'm just going to do that quickly, shortly for you to see, and then we'll see how best you can do. But the interval is going to be what? What is the interval going to be? It's just going to be X. It's going to be what? First one, 3 is less or equal to what? X, because it starts at what? 3. Look at portion BC. It starts at 3 and ends at what? 6. You understand me? So let's proceed. So this is what, let me put it over here. So this is portion what? BC. Very beautiful. Or better still, I could come and put it over here so that you can have a correct overview. So let me put portion BC over here. So this is this portion BC. So that is our portion BC. So we said that we are considering the left-hand side. Okay, we are still considering the left-hand side because that would have been the easiest. We can still consider the right-hand side, though, but let's maintain the left-hand side so that if you understand that one very well, we can continue with the right-hand side as well. So we said that considering the left hand side. So we are considering the left hand side. So that is our interval is going to be what? That is x is no. The portion B was what? 3. You see. So it is what? 3 meters is less or equal to what? X. Less or equal to what? 6 meters. So this is the interval we are going to use over there. So look at from the free body diagram. From here, you see, we are going to draw the cut because this is the part that we are considering. Okay, we are just going, because we are considering the left hand side, this is the part we are going to draw. You see. So look at how I'm going to do that. So I'm going to draw that part, and this is how it's going to look like. Okay. So first one, we have our reaction. And this is where the cut took place. And then we have a reaction like that. Okay, so we have a reaction like that. So you see that the first one, we say we don't know. Okay, but here is A. So that here is A. And after that, we had even a different portion over it. That was portion B. You see, 20 kilonewton. Yes. And then from there, here is what? But the first one, as I was telling you, this reaction A was for 20 kilonewton. Let's put it over there. But the calibration is where I need your maximum attention. Okay. The first one is what? X, as I told you. Okay. We are on portion 2, so you should know that definitely you are going to have 2 calibrations. So the first one is what? X. Then the other one will be what? Take note of these terminologies. From here to here was what? 3 meters. So you can say that this is calibration 1 and this is calibration 2. Good. So here will be what? X minus 3. You understand? X minus 3. X minus 3. So as simple as that. This becomes your origin, which you are not supposed to forget. Anywhere there is a cut, there is an origin over there. And then you draw your rules that are going to be using. Okay. So the first one was moving towards this direction. The other one was moving downwards. And then you label it nicely. Then you can start. You start from your shear force values. You come and do your bending moment values. And then you can go and take your last cut. Then you draw the diagram. To enhance understanding, I have to divide the lecture video into 2 so that it has not become too long to watch. So very soon, the lecture is going to come to an end. Do well to get or watch the part 2 of the lecture video so that you can get a detailed understanding of the concept. In the lecture 2, I'm going to calculate for the shear force values and bending moment values, and also draw the shear force and bending moment diagram for this particular problem. This is the past question that we are solving. So please, in a very big, please take it very, very serious. So I said that this is the moment. Okay. your hot neutral axis, and then this is hot your shear force, which is the hot thing. You see, very good. So from here, what are you going to do? You're going to calculate for your shear force values. It's just as simple as the same thing that we did initially. So over here, your shear force values are going to be hot. So these are your shear force values. Your shear force values. You see. So the shear force values, I told you that they are the people that are moving in the hot y-axis. So it's not anything too difficult. They are the people moving in the y-axis. It's not anything too difficult like that. So look at it. As simple as ABC. Then from here, what do we do? You come and put down our rule. Okay. So shear force value, people that are moving in the y-axis. So we say our sum of all forces moving in the y-axis, we equate it to what? 0. Very good. From here, what are we going to do next? We can calculate for the shear force values, and then we can choose to say a goodbye. We meet in part 2, and life is now much more easier. Very good. Very good. So from here, what are we supposed to note? What are we supposed to note? Good. The shear force values I was telling you about is the people that are moving in the y-axis. So this 20 kilonewton is moving in the y-axis. This guy is also moving in the y-axis. And who again? This thing is also moving in the y-axis. So this one is moving upwards, so it's positive. So positive 20. This one is moving downwards. This one is going to be negative, minus 20. Okay, minus what? Thing. From the cardinal point I show you, the same understanding. Okay. So the first one is what? 20. 20. So the 20 is positive, okay? Minus what? 20. Because it's moving downwards. Minus another what? 20. No, minus 20. Okay, that will be all. Minus 20. So minus 20. Equal to what? 0. If you group license, what are you going to get? This is going to give you what? 0 minus v is equal to what? 0. Finally, you realize that we can say that therefore our v is equal to what? Finally, therefore we can say that our v is equal to what? 0 kilonewton. Okay. 0 kilonewton. 0 kilonewton. And this gives us a what? Constant. Okay. So this makes our shear force value to be what? Constant, because there is no variable like x attached to it. So from here, it's just we apply the traditional method. So this time it's going to be hot. We are not going to use AB anymore. We are going to use hot BC because it is portion hot. BC that we are considering. So we say that hot at 3. We say that hot at x is equal to 3 meters. VB is equal to what? 0 kilonewton. Also, we come and say that at x is equal to what? 6 meters. VC is equal to what? 6 kilonewton. As simple as it's equal to 0 kilonewton. As simple as ABC. Okay, so that is the last thing we're going to do, and then we calculate for the bending moment values in part 2. Yes, let's do it that way. So I say that at what? At x is equal to what? 0. Our what? Vertical force at B is equal to what? 0 kilonewton. 0 kilonewton. Okay. And also at what? No, the first one is 3 meters. Okay. The first one is 3 meters because the interval started from 3 to 6. Okay. Yes. So at x is equal to 3 meters. So at x is equal to 3 meters, your vertical force at B is equal to what? 0 kilonewton. And also at x is equal to what? 6 meters. Also at x is equal to 6 meters. Your vertical force at C, or let me say your shear force, your shear force at C is equal to what? 0 kilonewton. This thing we are talking about is shear force. It's not vertical force. It is shear force. So your shear force at C also becomes what? 0 kilonewton. Okay, 0 kilonewton. Okay. So from here, what are you going to do next? The next thing you are going to calculate for is the what? Your bending moment values. Okay, you come and calculate for your bending moment values. So let me write over here the bending moment values. When we meet in part 2, we'll see how best to dissolve that. So this is the bending BM values. Okay, so these are the bending moment values. So you don't have to forget to pull down the rule. The rule, of course, that is what will give you the mark. So let's put the rule down. That is, you put the rule. This will all anti-clockwise moments are positive, so that sum of all moments moving about the origin O should be equal to what? 0. Then we are good to what? Go. Okay. Then we say we are good to go. So on this note, my name remains Megabyte the physicist. Don't forget to see me in groups, in person, one-on-one, in case you encounter any challenges related to what we have learned. So far. It is very, 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 very important. Good students should do what to type their questions in the comment section. Type your questions in the comment section. I'll do what to review them for you. Also, don't forget to subscribe to the channel so that anytime I release a video, you can be given a feedback. Don't forget to like the videos and share for more. All right. So meet me in part 2 of the lecture video, and life is going to be much more easier. Thank you all very much for your time, and may God bless you all. Bye bye.